Hello and welcome to another video about propositional logic. In this video we're going to do one more proof example using our laws of logic. In the previous ones we've proved that things are tautologies. In this video we're going to talk about how we prove that two statements are equivalent statements. So that's what we're going to do. We still have our list of laws up here so that we can reference them as we go. All right, so the statement we are going to prove this time is not P or not P and Q is equivalent to not P and not Q. Now there are two ways we could do this. We could either start with this statement and expand it using our laws into this, or we can start with this statement and reduce it using our laws to this, right? Because this is more complicated than this. We are going to do this side. We're just going to reduce this statement, but there are some circumstances where you might want to choose to do the opposite if it looks simpler. In this case, I think this is going to be simpler. All right, so we start our proof like this. Essentially, all that we're going to do is reduce this into this statement. It can be a little trickier than proving tautologies because you have to get it into exactly the right format, right? You can't just get it down to truth or you know, like you would do with a contradiction, get it down to falseness, right? You have to get it down to exactly this statement. So it can be a little tricky. All right. So we start with our given statement, P or not P and Q. That is our given statement. And we say given. And our first step is going to be to get that negation out of the way. We don't like that negation on the outside, and our laws that deal with taking outside negation and moving it in are De Morgan's laws. They take outside negation and move it in. And in this case, we're doing De Morgan's over an or. So we choose this first of De Morgan's laws, and we move the negation in and swap it to an and. So let's just do that. So we now have not P and not P and Q. De Morgan. We again have negation outside of a more complex statement, so we're just going to do De Morgan again on the inside. So not P and... this time we're doing De Morgan over an and, so we're going to move the negation in and switch it to or. So we now have not P or Q. De Morgan. All right, great. Now we take, we're going to want to reduce this using our double complement law. So not P and P or Q by the double complement law. Hooray, hooray. All right. Now we have two different operators, and we want to get it a little bit more. We want to get these two together, but they're under different operators. So we have to have, we're going to use our distributive properties, right? So we have an and over an or. And over an or means that we get ands in the little ones and or on the big one, right? So we're going to say not, whoop, we need another paren, not P and P or not P and Q, right? Yes. And that is by, oops, sorry, this is always not Q because I just missed writing that in the De Morgan step. I thought there was something that looked wrong. Right. And this is by distributive. All right, so we have not P and P together, which we know is going to be one of our complement laws, but we're supposed to have P and not P, in that order. So we're going to use a commutative property and say P and not P, or not P and not Q, by the commutative property. We go to 7, and we can cancel that out. So we can say false or not P and not Q by the complement law. Now this looks like we should just be able to use the identity property, but again we have to switch the order. So we're going to use the commutative property first. So we go to step 8, we switch this to not P and not Q, or false and then we can say, using our identity property, that this has been reduced to not P and not Q using identity. And so we have, in the end, we've reduced this statement to this, and so we have not P and not Q is equivalent to not P and not Q, so QED. Hurrah! So this is how you prove equivalency using our laws of logic. Now again, you can always just do this with a truth table, but sometimes it's good to use your brain to work through using these laws. So this has been our last video where we're doing this. There will be some later videos where we talk about other ways to do proofs using these laws. But this is the basic video about how you use laws.